Okay, good day viewers, thanks for watching. In today's class, I want us to learn simple AC circuits. Simple AC circuit. First of all, what is AC circuit? Now, I want you to know that an alternating current changes direction periodically as a result of changing of the EMF. As a result of the changing of the EMF. Are you there? Now, these changes is what we can actually call simple AC what? Circuit. Are you there? The circuit in which alternating current flow is called what? Simple AC circuit. Are you there? The circuit in which an alternating current disturbing me. The circuit in which an alternating current flows is called what? It's called simple AC circuit. Are you there? Now, looking at this diagram, here is VO. Are you there? And this also using IO. You need to know that we have what we call IRMS. This signal is known as, okay, let me say terms in simple AC circuit. Terms in simple AC circuit. The terms in simple AC circuit. We have this. This is called root mean sphere. The I there, you know I means current, right? Root means sphere current. Are you there? We have VRMS. This is root mean sphere voltage. Are you there? We have so many things like WT is equal to theta, and this is equal to phase angle. We have W, which is angular frequency. Are you there? So, these are the major ones you need to know. Do you get the point now? Now, and there are formulas you need to learn here. Formulas like root mean sphere is equal to IO. Again, before then, you need to also know what IO and IV and VO is. We need to also know what IO and VO is. IO is equal to, we call it peak current or maximum current. VO is equal to peak voltage or maximum voltage. Are you there? So you need to know all these things. I believe you know normal I is equal to current, R is equal to resistance, V is equal to what? Voltage. So now, the next thing now we need to learn here is that I this is equal to IO. IO sine WT. IO sine WT. Are you there? Now, you also need to know, I think I've listed these things here now already. Let me still continue. Where IO is equal to peak current. WT is equal to theta, which is equal to phase angle. So this is equal to root mean square current. So we also have V arrow mx. This is equal to VO sine WT. It's not applicable to this. So here we say where V arrow dot mx is equal to root mean square voltage. VO is equal to peak voltage or maximum voltage. Are you there? What else again? WT is equal to theta, which is equal to phase angle. Now, don't forget that I root mean square is also equal to IO over root 2. Are you there? It's also equal to IO over root 2. That is to say that IO, if you make IO sort of formula, IO is equal to root mean square current times root 2. You need to note these formulas. Are you there? Also know the same can be applied. The same is applicable to V arrow m dot s is equal to VO over root 2, or you call it sort 2. If you make this subject of formula, you have VO is equal to V arrow dot m dot x times root 2. Take note of this. Are you there? So, having known this now, another thing I want us to know is I want to teach you how to know AC circuit diagram in case you encounter it in a question. Now, let's start off with AC circuit containing resistance only. 1. AC circuit containing resistance only. But before that, I want you to know something. Wait, let me show you something before that. This will help you. It will help you to have a balanced understanding of what I'm about to do. Symbols, right? Symbols to note. Symbols to know in AC circuit. Symbols / diagrams to know in drawing AC circuit diagrams. But preferably symbols to know. Are you there? The symbols I wanted to know are nothing but this. One, we have something like this. Or what do you call this? This inductor. This is what? This is what? Tap that boy. You should come here. Come this side. Come. This is what? Call this inductor. Now we have something like this. What do you call this? This is resistor. This is what? Resistor. You call it what? Resistor. We have something of this nature. What is this? Capacitor. You call it capacitance. Are you there? Capacitor. I think that is all. The important, no, not all. 4. We have something like this. Or in circle, or like on its own. It is called what? Voltage. It's called what? Because you're going to encounter these things in your diagram, so that when they ask you to draw or find an AC circuit containing resistance only, you know how to follow it. Are you there? So let me add small water here. So now we've known these symbols. Now another thing I want us to note is there are diagrams I want us to note. Something like this. We call here VO equal to VO sine WT, and here I is equal to IO sine WT. Now another thing I wanted to note is phasor diagram is what? You're not responding. Is phasor diagram. Now, what is phasor diagram? Right. Phasor diagram is a diagram in which an AC circuit is represented by voltage and current in a straight line indicating the direction and magnitude of current. And the diagram is like this. Here is voltage and here is what? Current. Are you there? So another thing I want us to learn now is let's dive deep into AC circuit containing resistance. After resistance, we'll look into AC circuit containing capacitance. After that, AC circuit containing inductance only. Then we'll then move over to AC circuit containing both resistance and capacitance. Let's know the diagram so that we know how to solve questions in this topic. Now, one, AC circuit containing resistance only. How do you draw the diagram? Remember, I have given you the symbol of resistance. Are you there? Huh? Are you there? I have given you the symbol of what? Resistance. Now, you draw the diagram like this. Yes, voltage. Here's what? Voltage. And here is what? Resistance. Resistor. Huh? So, you know that V is equal to IR. Is that correct? Huh? V is equal to what? IR. And R is equal to V over I. Oh, I need to clean this place. I need to clean this place. Now, here now, the V here is equal to VO sine WT. Are you aware? While the I is equal to IO sine WT. Are you there? So if you relate it here, you're going to have VO sine WT over IO sine WT. Are you there? So this will cancel this. You're going to have R is equals to VO over IO. Are you there? Yes. Now, let's talk about AC circuit containing inductance only. Number 2, AC circuit containing inductance only. Are you there? Yes. Now, what is inductance? Inductance is an opposition to the change of current. Are you there? Inductance is an opposition to the change of current. So in an AC circuit, inductance affects the continuous changes of what? Current. Are you there? So now, what I want us to learn here is the diagram, because that is what will lead us to problem solving. Are you there? I have told you that inductance is an opposition to the change of current. It can also be defined as an opposition to the flow of current. Are you there? So now, let's draw inductance diagram. Are you there? Call here VL. Call here L. Are you there? So in the diagram now, I is equal to IL. So here now, inductance is represented by L. Are you there? It is represented by what? L. And measured in ohms. And measured in ohms, in brackets, something like this. Likewise, resistance, you know the presentation is what? R. Resistance is also measured in what? Ohms. But I didn't state it because we are conversant with what? Resistance. Are you there? So here, you need to know that resistance is measured in ohms, in bracket this. Are you following now? Inductance is measured in ohms. Resistance is also measured in what? Ohms. Now, the diagram here, but before this, let me give you phasor diagram first. Let me give you phasor diagram. It's very important. Let me give you phasor diagram. Let me give you what? Phasor diagram. And if you have something like this, you can say that VL is greater than what? IL. That is, here is VL and here is what? IL. So here we can say that current lags behind voltage by 90 degree. Current lags behind voltage by 90 degree. So now, inductance on its own can be represented as what? SL. S what? L. And is equal to what? WL. And this is equals to 2 pi FL. Because where W is equal to 2 pi F. Are you there? So note this formula of inductance. Note this formula of inductance. Are you there? I want to clean this. Now, there's a diagram here. And also, no, let me clean here. Let me clean everything. Now look at this diagram. So here is 90, and here is VO, V equal to VO sin WT. And here is 180, here is 270. The other part is what? 360. Are you there? The other part is what? 360. Now, under capacitance, what we did now is what? Okay, we are still in inductance, right? Now, number two. AC circuit containing what? Capacitance. Containing what? Here, what is capacitance? What is capacitor? Now, look at the diagram here. Normal capacitor is something that stores energy, is that correct? So capacitance is in phase, is in relation to what? Voltage. Are you there? So now, this is it. We use this to represent capacitance. So we can call this VC, and here is XC. Are you there? Here is what? XC. Are you there? So now, capacitance is better than what? Capacitance. So here we can say that based on the phase diagram, we can say that voltage lags behind current. The phase diagram of capacitance, phase diagram of AC circuit containing capacitance. If here is VC and here is IC, so we say that the voltage lags behind the current. So here we say that voltage lags behind current by 90 degree. By what? 90 degree. So the next thing I want us to learn, number 3, is capacitance, AC circuits containing both inductance, capacitance, and resistance. Are you there? So now I want to clean. Now number 3. AC circuit containing resistance, inductance, and capacitance. Are you there? Now, how do you draw this? Remember that I have taught you resistance, I have taught you capacitance, and I have taught you inductance. Is that correct? Now, using the 3 symbols, it can enable you to draw a good diagram on AC circuits containing inductance, reactance, and what? Inductance, resistance, and what? Capacitance. Are you there? Now, look up now. This one now is for resistance. Is that correct? Now, this one now is for inductance. Why this one is for Capacitance. Huh? So now look up. You call here, from here to here, call here VR. Huh? From here to here, call here VL. From here to here, call here VC. Are you there? Huh? So now, here we're going to learn impedance. Impedance is an opposition to the flow of what? Current. Are you there? Impedance is an opposition to the flow of current through resistance, inductance, and capacitance. Are you there? So this impedance, it is noted by capital letter Z. Are you there? Are you there? It is noted by capital letter Z. You are disturbing me. So now look up. Based on this now, we'll call this impedance here now V R dot M dot X. V square is equal to V R square plus bracket VR. I don't want that noise. People are distracting me. Bracket VL minus VC all square. Are you there? So now look up to this proving now. This VR square will be equal to IZ square. Now this VR square will be equal to IR all square. And this VL square will be equal to IXL square. This VC square will be equal to IXC square. Are you there?
Yes.
So what are we going to do? Anyway, with this, let me repeat this V square R dot M dot X equal to VR square plus bracket VL square minus VC square. Are you there?
Yes.
So now, this is IZ square equal to IR square plus bracket IXL square minus IXC square. Are you there?
Yes.
Now, this is I square Z square equal to I square R square plus bracket I square XL square minus I square bracket XC square. Are you there?
Yes.
Are you following up now?
Yes.
Now, I square Z square is equal to I square R square. Common factor here is what? Plus I square. Now, in brackets, now this is X square L minus XC square. Are you there?
Yes.
Now, here now we're going to do what? Factorize. We've done that there. This is I square Z square equal to I square R square plus, okay, I said common factor, right?
Yes.
So let me just state what we are going to do there. Let me state so that I won't forget. So this is, you factorize on the right hand side. If you do that, I think we can continue over here. Remember, I have something like this: I square z square equal to I square r square plus I square into bracket xl square minus xc square. Are you there? So I say we should factorize there. Is that correct? So now, if we do that, we have I square z square is equal to, one factor now will be what? I square, then bracket r square plus small bracket xl square minus xc square. Close the small bracket and close the big what? Bracket. Knowing fully well that I square times r square will give us I square r square. Now, good. Raise the light up. Good. Now, plus I square times x square l will give us I square sl as we had over there. Then I square times minus minus x square c will give us I square x square c. So what are we going to do? We divide throughout by I square. When we do that, we're going to have I square z square divided by I square equal to I square over I square, then bracket r square plus small bracket x square l minus xc square. Are you there? Yeah. So this we cancel this and this we cancel that. We have z square is equal to bracket r square plus bracket x square l minus x square c. Close the small bracket. Now, make z subject of formula. You have z is equal to root r square plus bracket x square l minus xc square. So this is the formula for impedance. No, sorry, this is the formula what we got now. Now, but z is equal to, sorry, v is equal to what? I is equal to v over z. Are you there? I is equal to what? V over z. But I is equal to v over z. Do you know how? Remember that this place now that will v square, use iz. That is to say that v is equal to iz. Do you understand now?
Yes.
V is equals to iz. So I there is equals to what? V over, that's what I'm saying. Do you understand now?
Yes.
But this is what I want us to learn. So from here now, we can say that V is equal to IZ. Can say that I is equal to V over, what is our Z? Impedance, that is root R square plus bracket X square L minus X square C. So where Z is equal to impedance and V is equal to voltage, are you there? I is equal to current. So this formula is for finding current in an impedance.
Yes.
Do you understand now?
Yes.
So I want to clean here. Now this one will be number what now? Check your book. Number what? 4. So number 4 now. AC circuit containing resistance and capacitance. So here, this is it. Are you there? So this is VR and this is VC. So how do we solve this now? VR dot M dot X square is equal to VR square plus VC square. Are you there?
Yes.
So this is IZ square based on what I taught you before equal to I arrow all square plus what? IXC square. Is that correct? So now this is I square Z square equal to I square arrow square plus I square X square C. So this is I square Z square equal to, common factor here is what? I square into bracket arrow square plus X square C. Now divide both side by I square. You have I square divided by I square, that is I square Z square equal to I square bracket arrow square plus X square C divided by I square. So this will cancel, right?
Yes.
So we then have that Z square is equal to Z square is equals to arrow square plus X square C. So Z now is equal to root arrow square plus Z square C. That is the formula for AC circuit containing resistance and capacitance. Are you there? Now, phase diagram now. The phase diagram, we draw something like this. Here is V. V, let's say VC, and here is IC. So we can say that IC is greater than VC. That is to say that voltage lags behind current by 90 degrees. Are you there? So now let's move over to AC circuit containing resistance and inductance. But in terms of leading and lagging, let's have a diagram like this. Call here VB, call here VA. So that VB leads by 90 degrees, while VA lags by 90 degrees in terms of leading and lagging. In terms of what? Leading and lagging. This is in terms of leading and lagging. Are you there? Are you there?
Yes.
So I want to clean here, this side. Now, number what now? Number 5. Here now is AC circuit containing, we've done resistance and capacitance.
Yes.
So AC circuit containing resistance and inductance, containing what?
Resistance and
You say resistance, what do you want to say before inductance? This AC circuit containing what? Resistance and inductance. Now look up, look at the diagram now. Are you there? Now, I and R are measured in ohms, comma, they have the same current. They have the same current, but different voltage. Are you there? So now here this is V square R dot M dot X equal to VR square plus VL square. So here from here to here is VR. From here to here is what? VL. Are you there? So this is IZ square equal to IR square plus IXL square. So this is I square Z square equal to I square R square plus I square XL square. Is that correct?
Yes.
Attention. So this is I square Z square equal to, common factor here is what? I square. Is that correct?
Yes.
Now bracket R square plus XL square. Are you there?
Yes.
Now divide both sides. Divide both sides by coefficient of Z, that is by I square. We have I square Z square equals to I square bracket R square plus XL square over I square. So this is Z square equal to R square plus X square L. So Z is equal to root R square plus X square L. Are you there?
Yes.
Now, this is AC circuit containing reactance and inductance. Now, voltage leads the current by angle theta. Are you there?
Yes.
You can see that voltage. I want to clean here.
Yes.
So here, we can draw a diagram here, under here. Here is theta, here is V, here is I. We can say that voltage here leads the current by angle theta. So what angle is here? What angle is here? If it's like this, what angle is here? If it's like this, is what? Now it's a business. So this is not really 90. Are you there?
Yes.
This one is 90. So if it's like this, I, we also see that voltage leads the current by what? You can say V C greater than IC or whatever. So you can say voltage leads the current by 90 degree. But here, voltage leads the current by angle theta. Are you there? So now let's talk about reactance and capacitive reactance, inductive reactance. Are you there? Are you there now?
Yes.
Now let's talk about capacitive reactance. Capacitive reactance, inductive reactance. One, call these terms in AC circuit. 2, 3, reactance. I place reactance in number 3. Now, what is reactance? You know, reactance is opposition given to the flow of current in an AC circuit, either through a capacitor or an inductor, and it is noted by X, measured in what? Ohms. Are you there? You see that reactance is what? Reactance is an This is an opposition given to the flow of current, either through inductance or capacitance. Are you there? And it is denoted by X. Are you there? Measured in ohms. Measured in ohms. Are you there?
Yes.
Now, for capacitive reactance, this is an opposition given to the flow of current. This is an opposition given to the flow of current through a capacitor. Through a what? Through a capacitor. So it is Xc, and this is equal to 1 over what? 1 over W. W C, that is 1 over 2 pi F C. Are you there? Are you there?
Yes.
Now, I want to clean this side. Now, inductive reactance. Inductive reactance. This is an opposition given to the flow of current through an inductor. It is noted as XL equals to WL, and this is equals to 2 pi FL. Are you there? 2 pi FL. Now, let's talk about resonance. Resonance in L, C, and R. So, we know what L is. Where L is equal to inductance, C is equal to capacitance, and R is equal to resistance. Are you there? So now, already we know that XL is equals to 2 pi FL, and XC is equals to 1 over 2 pi FC. Already we know what resistance is now. Resistance is equal to what? V is equals to IR. Resistance is equals to V over I. Now, let's talk about resonance in inductance and capacitance. Resonance in inductance and capacitance. Here we say that SL is equal to XC, or you say XC, or XC is equal to XL. Are you there?
Yes.
Now, SL is equal to 2 pi FL, while XC is equal to 1 over 2 pi FC. So, XL equal to XC. This is 2 pi FL equal to 1 over 2 pi FC. Now, I want you to know that both in inductance, capacitance and resistance, the resonance here, they varies with what? Frequency. Are you there?
Yes.
Resonance, the same frequency is experienced in each resonance. Are you there?
Yes.
Now, we have 2 pi FL is equal to 1 over 2 pi FC. When we cross multiply, we're going to have 2 pi FL times 2 pi FC equal to 1. 2 pi times 2 pi will give us 4 pi. Pi what? F times F will give us F square. LC equal to 1. Now we're looking for frequency, right? Frequency is equal to 1 over 4 pi LC. Are you there?
Yes.
So what are we going to do? Go over to this side. So now, remember from here, we said 2 pi FL times 2 pi FC is equals to 1. So 2 pi times 2 pi, this will give us 4 pi square. F times F square LC equals to 1. So now, we want to make F subject of what? Formula. So F is equal to 1 over 4 pi square LC all square. Are you there?
Yes.
So F is equal to yes, square root. Are you there? So this is 1 over, my version now, I'm trying to conserve time. Are you there? So this is 1 over root 4 pi square LC. Are you there? So now F now is equal to 1 over 4 pi square, then 1 over 2 times LC square. Hope you know, based on, in this, I want to clean here. So from here, remember we have root 4 pi square L square. According to indices, in indices, fractional index law. According to indices now, in fractional index law, when you have a raised to 1 over 2 is equal to root a. Are you there?
Yes.
Now, here will be 1 over 2, not LC square. Are you there?
Yes.
Now, to finalize this now over here, we say that F is equal to 1 over 2 pi square times 1 over 2, then times LC, raised to 1 over 2. So F is equal to 1 over 2 pi, this 2 pi square times 1 over 2 times LC raised to 1 over 2. This 1 over 2 here is representing roots. Are you there? So now, this we cancel out. F will be equal to 1 over 2 pi times bracket LC raised to 1 over 2. So therefore, F is equal to 1 over 2 pi root LC. This is the how to find frequency. This is resonance. Are you there? This is the what? Resonance. So let's talk about power. Let's talk about power. I want to clean here. Let's talk about application of resonance. Application of resonance. 1. Resonance, right. 1. Resonance makes transmission and reception of radio wave possible. What did I say? Resonance makes transmission and what? And reception of radio wave. 2. It is applied in broadcasting industry. It is applied in broadcasting industry. It is applied in broadcasting industry. 3. It is applied in sound instruments. Are you there?
Yes.
It is applied in sound instruments. It is applied in sound instruments. Let's go through it again. 1. Resonance makes transmission of reception of radio wave possible. Are you there?
Yes.
2. It is applied in broadcasting industry. 3. It is applied in sound instruments.
Yes.
Now, last but not the least, power in AC circuit. In the other diagrams I want us to know, but that will be later. Power, right? Power in an AC circuit is the ratio of doing work, and it is the product of voltage and current. Right? Power in an AC circuit is the what? And it is the product of what? Is the product of current and voltage. Sit on the board. Power in an AC circuit is the ratio of doing work, and it is the product of current and voltage. That is P is equal to IV.
Yes.
But based on AC circuit, you can have P is equal to IV cos theta. Are you there?
Yes.
You can also have P is equal to I square R over 2. Hope you know.
Yes.
Depending on the contents of the question. Now, based on what we did in frequency, we can have a diagram like this. You call here frequency, and you call here what? Current. You call here what? Current. Are you there?
Yeah.
So we've actually come to the end of this, what is it called? End of this AC circuit class. If not for time, we have a lot we would have done in terms of diagram, but because of time, I think we need to stop here. Are you there? Yeah. So in our next class, in solving many questions related to AC circuits, I will introduce other factors like diagrams I didn't include in this video, in that class. Are you there? So before we call it a night, because this is almost to 7. This is night now. We've been here since from maths class to chemistry class, and from chemistry class finally to what? Physics class. Now, there's a diagram like this under resonance. There's a diagram like this. This marker is not writing well. Here is VR, VC, and VR. So we can say that tan theta is equal to VL minus VC over VR. So we can say that tan theta is equal to IXL minus IXC over IR. So tan theta is equal to, common factor here is what? I. Is that correct?
Yes.
into bracket xl minus xc over ir. So I will cancel out so that we have that tan theta is equals to xl minus xc over r. Over what? R. Over r. So you need to take note of this formula. So good day. See you in my next class.